Imagine everything you thought you understood about attraction was incomplete. We grow up thinking of attraction as gravity alone. An apple dropping, a planet circling the sun, our feet held firmly to the ground. But what if that's just the surface of a far deeper universal story? Today we're peeling back the layers of what pulls things together, from the tiniest particles to the largest galaxies, and uncovering the science that shapes reality itself. At the heart of the universe, gravity is the most familiar force. It's the invisible glue that keeps planets locked in orbit, shapes stars, and sculpts galaxies. Every object with mass bends the space around it, creating a well that draws in other objects. Earth's gravity gives weight to our bodies, makes oceans stay with the planet, and ensures the moon dances in rhythm with us. Yet, gravity is actually the weakest of the fundamental forces. Astonishing, considering it shapes entire worlds. If you drop a paperclip, a small magnet can overpower Earth's pull in an instant. That should hint at something bigger. Attraction is not just about gravity. Zoom into the atomic level, and the universe starts playing by different rules. Electromagnetism takes center stage, binding negatively charged electrons to the positively charged nucleus. This invisible tether is what keeps matter stable. Without it, atoms would simply dissolve into chaos. Electromagnetic attraction explains why your phone screen responds to touch, why magnets snap onto your fridge, and why chemical bonds form to create the molecules of life. At this scale, attraction is a dance of charges, a balance of opposites pulling together. Even deeper inside the atom, an entirely different kind of attraction rules: the strong nuclear force. Imagine protons, each positively charged, trying desperately to repel one another like two magnets facing the wrong way. They should fly apart, but they don't. The strong force, far more powerful than electromagnetism, binds them tightly, holding the atomic nucleus together. Without this fundamental glue, stars could not burn, no carbon would form, and life itself would have no foundation. Attraction here isn't gentle, it's ferocious, billions of times stronger than gravity, yet operating at distances smaller than a single proton. There's also the mysterious weak nuclear force, quieter but equally essential. It governs the decay of particles, allowing stars to fuse hydrogen into heavier elements, seeding the cosmos with the ingredients for planets and biology. Without this subtle kind of attraction and transformation, the periodic table would remain barren and the universe would lack complexity. Move back outward to the vastness of space, and attraction changes its tune again. Gravity orchestrates the cosmic ballet, shaping stars, birthing galaxies, and weaving an intricate web where matter clumps into filaments stretching millions of light years. Yet even here, gravity isn't the whole story. Astronomers have discovered that galaxies spin faster than gravity alone can explain, hinting at an unseen influence: dark matter. It neither emits nor absorbs light, yet it seems to anchor galaxies, an invisible skeleton for the cosmos. Dark energy, even stranger, pushes the universe apart, creating a tension between forces of pulling and expanding, attraction and repulsion, that dictates the fate of everything we see. The science of attraction isn't limited to forces we can label. Consider chemistry, where molecules assemble in elaborate patterns, forming crystals, DNA, and the air you breathe. Attraction at this level arises from electrical interactions, hydrogen bonding, and quantum mechanics, the subtle whispers of probability shaping reality. On a biological scale, cells communicate, lock together, and build tissues, all because of molecular affinities. Life itself emerges from billions of years of things sticking in just the right way. Then there's us. Humans are drawn to each other through biology, psychology, and emotion. Oxytocin, dopamine, and pheromones weave invisible threads of connection. Evolution has fine-tuned us to seek companionship, to form bonds that increase survival. It's attraction on a different plane, less about physics, more about meaning. Yet, it's still a force of nature, binding societies, inspiring art, and driving every story we tell. Across every scale, attraction is the architecture of reality. Whether it's the iron grip of gravity keeping the moon close, the fierce embrace of the strong force inside an atom, or the tender pull between people, the universe thrives on connection. Matter clings, galaxies cluster, stars gather companions, and we, products of this cosmic web, continue the pattern in our relationships, our curiosity, and our endless search for belonging. So next time you see an apple fall, don't just think of gravity. Think of the particles inside it, glued together by forces stronger than anything you can imagine. Think of the Earth holding it, the Sun holding Earth, the Milky Way binding countless stars, and the hidden dark matter scaffolding it all. Think of the invisible bonds that built you, your family, your friends. Attraction is not just a force, it's the story of existence, written from quarks to quasars. The science of attraction reaches beyond gravity. It is the reason atoms persist, planets endure, galaxies spin, and hearts connect. The cosmos is not a cold, empty void. It's a universe of relationships, where everything, everywhere, is reaching for something else. And in understanding that, we glimpse our place in the grandest connection of all.